Hey guys, so today we're going to talk about modeling quantities. And you've got the state standards here. Remember the state standards, we cover those kind of in several different lessons, but the success criteria tells us kind of what you need to learn in this lesson. So these come from your standards, but again, we cover the standards sometimes in multiple lessons. So today we need to be able to use ratios to solve real world problems, use rates to solve real world or real life problems, and convert units and rates. Your vocabulary: ratio is a comparison of two quantities, and proportion is an equation stating that two ratios are equivalent. Make sure these are in your notes. All right, example 1. You can take the measurement shown in the diagram. The right triangles created by each object and its shadow are similar. Can the tree fall onto the house? All right, so that's the question we want to answer. Can the tree fall on the house? All right, and there's a hint here. Remember, the triangles created by each object and its shadow have two congruent angles. So the third angles are also congruent and the triangles are similar. So we know these are similar triangles, so we can set up a proportion to solve. So what information do we have? The height of the person is 6 feet tall. Their shadow is 8 feet tall. We don't know how tall the tree is, but we know it casts a 30-foot shadow. We also are given that the house is 25 feet from the tree. So we need to know if that tree would fall on the house if it fell. All right, so the first thing we can do is set up our proportion. We know that the shadow is compared to the shadow because these are proportional. So we're going to say 30. Okay, that's the length of the shadow of the tree. And that would be similar to the shadow of the person. All right, so we don't know how tall the tree is, so let's use height of the tree. Let's use h. You can use x, any variable you want. That's our unknown. That's what we're solving for. And that is compared to the height of the person. And the person is 6 foot tall. So we know we can cross multiply when we have a proportion. So we're going to have 8 times h equals 30 times 6. 6 times 3 is 18. Add a 0. All right, divide both sides by 8. 180 divided by 8 is 22.5 feet. Since we're using feet as a unit in all of these, then h would be solved in feet as well. All right, so can the tree fall on the house? We can see here that the distance from the house to the tree is 25 feet, and we just found the height of the tree is 22.5 feet. So because 22.5 is less than 25, so the tree cannot fall on the house. So the tree, thankfully, cannot fall on house. All right, let's move on to the next example. All right, a couple quick proportions here. So remember, we're just going to cross multiply, so we can go 12x equals 9 times 4, which is 36. Divide, we're solving for x, so divide both sides by 12 to get x by itself. X equals 3. All right, and then you can always plug it in and check it. Is 3/4 equivalent to 9 over 12? It is, so that works very well. Same thing here, so I've got 14 times 2 equals 7 times y. So let's go 7y equals 14 times 2 is 28. Divide by 7, y equals 4. And 14 over 4, is that equivalent to 7 over 2? If you reduce both by 2, you get the same thing. So yes, that is equivalent. So you can plug those in quickly and check them. Same thing with here. Let's go 5 times z. 8 times 3 is 24. Divide by 5. Z is going to equal That's not going to reduce, so we're just going to leave that as just leave that as 24 over 5, I guess. And then we can do 8 divided by 24 over 5. Let's check that with the calculator. 8 divided by 24 over 5. And that should give us 5/3, and it does give us 5/3. Okay, so that one didn't come out nice and neat, but it still is the correct answer. So if you put this in your calculator as 8 divided by, put this in parentheses, 24 divided by 5, it's going to give you 1.666, and if you hit fraction, it's going to change that to 5/3. So this one is correct as well. Although we don't usually have answers like that, but still. All right, so number 5, reasoning. Are the equations A over B equal to C over D and AD equals BC equivalent? Are these equivalent? Okay, so A times D equals B times C. So those are using cross multiplication to set these up to solve. So is that an equivalent statement? The answer is yes. Those are equivalent. That's exactly what we were doing in each of these cases in order to solve. All right, example 6. The diagram shows statistics for a baseball pitcher. Use rates to compare the pitcher's performance in 2019 to his performance in 2020. All right, so if you look at the table here, this is 2019. He had 70 innings, 54 hits, 19 earned runs, 29 walks, and 100 strikeouts. 2020, here are the numbers for 2020 as well for the same categories. So it says a rate is a ratio of two quantities used in different units. You can write rates in many ways. For example, 10 meters per second can be written as 10 meters per second, 10 meters per second, 10 meters per second. All of these are very similar. They all mean exactly the same thing. They're just written slightly different. Okay? So it says in real life situations, you may need to choose your own units to solve. All right, so up here again, it says use rates to compare the pitcher's performance in 2019 to his performance in 2020. So let's just pick two things. Let's say we're going to look at strikeouts and walks. All right, so in 2019, he has 100. Let's make sure I'm on the right thing here. All right, so he has 100 strikeouts per 29 walks. All right, so this is going to be approximately equal to what? So if we do 100 divided by 29, that gives us about 3.45. All right, so that is 2019. And let's do the same thing for 2020 because we're trying to compare. So to compare, we have to look at strikeouts and walks for 2020 as well. So we're going to do 73 strikeouts over 20 walks. And that's going to be approximately 3.65. That's actually exactly 3.65. So looking at this, we can compare these. So we can see that the pitcher has fewer strikeouts per walk in 2019. Fewer because this number is less than this number. Okay, so this was, so 2019 has fewer strikeouts per walk. So that would be considered our unit, strikeouts per walk. And we got that because that's the two categories that we use to compare. Now, could you do the same thing with two other categories? Sure, you could. If you wanted to compare earned runs, okay, you would use this column. You could use earned runs per inning. so do 19 over 70 and 15 over 50, and you could compare those and see which year had more or less. And then the units would come from whichever column you used. All right, example 7, the table shows enrollment information for 2 colleges. Use rates to compare the enrollment at the colleges. Okay, so you can see here College A has 4,258 students enrolled. They have 288 of those are athletes. 72 of those are students with athletic scholarships, and 415 are students with academic scholarships. All right, student B has 7,120 students. 150 of those are athletes. 110 of those have athletic scholarship, and 826 of those have an academic scholarship. So, what 2 categories do you want to compare? First, let's compare how many athletes in College A out of the entire population there. So, we're going to say 288 athletes. 288 athletes out of 4,258. So if we reduce that, 288 divided by 4,258 is about 6.8%. Remember, you move the decimal 2 places to write this as a percent. All right, if we do the same thing for College B, we want to know how many athletes out of the total number of students. So let's say 150 athletes out of the 7,120 total students. So if we divide 150 divided by 7,120, we get 2.1%. All right, so we can conclude that there are more athletes per student in College A than in College B. That too looks kind of crazy. Still trying to get used to this new pen and things that I'm working with here. All right, that looks better. All right, so this is athlete per student for College A. And this is athlete per student for College B. All right, let's look at a different category. Let's look at how many athletic scholarships out of the total number of athletes. So let's look at College A first. So we're going to do 72. So that's how many athletic scholarships out of a total of 288 athletes. All right, if we divide that, we're going to get about 25%. All right, so we're going to look at the same thing for College B. So how many athletic scholarships out of the total number of athletes? So there's 110 scholarships out of 150 total athletes. So you can see that that's a larger percent. If you divide that, you get about 73%. So that's about 1/4 of College A athletes are on scholarship, and about 3/4, almost 3/4 of athletes from College B is on a scholarship. So I'm just going to put scholarship per athlete and scholarship per athlete since I'm running out of room. But anyways, you can compare those and see that based on just the number of athletes at these colleges, you're more likely to get an athletic scholarship from College B if you're an athlete there.